Hi everyone, in today's video I will be going over our Unit 4.3 test review. And this covers graphing, sine and cosine specifically. So we've got 4 graphing problems to do from start to finish. Number 1, y equals 5 sine of x minus pi plus 3. First off, I'm just going to write out the general information to know. This general equation is y equals a sine of bx plus c plus d at the end. And on top of that, this is a sine graph, so I always like to make a little drawing of what my goal image is going to be. It will also help me graph later without having to think too much about it. And we're going to have our 4 intervals here. So if we start at the origin, which is rare but possible, sine's first point will be inside that circle. Then it goes up to its max, to the midline, down to the min, back up to the midline. This is one full curve, and it's an S curve. So this is what we're looking for when we start our graph. All right, let's fill in the info. Amplitude, that's the absolute value of A. Focus on the absolute value when you have a negative A value, when there's a reflection. Otherwise, it's just whatever's an A spot. So 5. Period is 2 pi over B. So we have 2 pi over our B value here is just 1. It's in front of the X. So 2 pi. Interval is period over 4. Our period is 2 pi over 4. And reduce that, we get pi over 2. Phase shift, we take whatever is inside of the parentheses, so the bx plus c, and we just set it equal to 0. Here, that's going to require just a tiny bit of work, so I'm going to come down here to write that. So in those parentheses, we have x minus pi equal to 0. So all we need to do is we need to move the pi to the right side. This is subtraction, so I'll add pi to both sides. X is equal to, this is positive pi when you move it over. That's my phase shift. Now, of course, you don't have to write the plus if you don't want to. That's just for emphasis. Vertical shift, that's the d value at the end of the equation, plus 3. Domain, always negative to positive infinity. Range will be determined later. Let's set up the graph. So for our x values, that goes by our interval number, which is pi over 2. Now for these grids specifically, I prefer to write my numbers at the bottom just because when I write over top these lines and then graph on top of that, it gets a little messy, so that's just my preference. I am going to write out the unreduced fractions like I usually do and then reduce them below. So, starting with the first interval, this is pi over 2 or 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. Reducing where possible. I'm just going to rewrite this as just pi over 2. Drop the 1. 2 pi over 2 reduces to pi. 3 pi over 2 doesn't change. 4 pi over 2 is 2 pi. Same thing on the left side, except these are going to be negative. Negative pi over 2. Negative pi. Negative 3 pi over 2. Negative 2 pi. From here, we need to figure out where we're starting on our graph. And also, I forgot to mention, one easy way to check that the intervals here are correct is your 4th interval should match the period always. If these two don't match, then there's an issue. I have 2 pi, so I'm good to go. Next, we need to figure out where we're going to start. That is based on the phase shift and the vertical shift. So phase shift is plus pi, so positive pi is here. So we're going to go right pi, And then if it helps, I'll go ahead and draw that in. Here's my phase shift line. Phase shift at x equals pi. And then my vertical shift is plus 3, so through positive 3, up 3. So vertical shift plus 3. Where these two lines cross, this is my starting point. From here, we are now able to start actually placing points for our curve. And again, that's why I mapped this out earlier. It makes it easier when I get to this step. I already know what I need to do. So again, this is sine. We start inside the circle. This is where I'm going to place my first point. From here, sine goes to its maximum. And because I'm so high above the x-axis, just to make it a little easier on myself, I am going to redraw these notches here on my, what I now call my midline. And I only need to go out 2 because that's where 2 pi ends. You can keep going if you'd like, but I only go out the ones that I fill in. So let me fill these in real quick. Pro tip, put one notch on the 0 so you don't forget to graph it. So that covers all the notches I have down here. All right, so our next notch, our next interval, we go up to the maximum, and that's determined by the amplitude. This tells you how far up and down to move for max and min. So I need to move up 5 from here. Clearly, I'm going to go off the graph. So I'm going to take a moment and extend my y-axis. So I'm at 3, I need to go up 5 more. So I need to go up to 8. 5, 6, 7, 8. 1, 2, 3, 4, 5. Yes. So this is my max number. Okay. So that was the first interval to the right is the maximum. Then I go back down to the midline. And again, you can keep going if you'd like, but I'm at the end of my, I'm at the 4th interval here, so I'm actually going to stop there. And since we're shifted over, I'm going to have a lot more points to the left, but that's okay. And now is a good time to go ahead and sketch this half of the curve, or this part of the curve, I should say. So that's what we have so far. And then if it kept going to the right, it would go down to the minimum, so I'm going to draw it like that. Okay. Now let's go back left. Remember with sine, to be extra careful with it, it is not a mirror, so I'm not going to go up and down like I just did to the right. I'm going to do the opposite of that. If I go up from here, it's going to disrupt the pattern 100%, and it will look crooked. So if you do that, hopefully you catch on to that mistake pretty quickly. All right, next interval to the left. I went up to the right, so I'm going to go down to the left. And again, this is based on the amplitude, so I'm going to go down 5. 1, 2, 3, 4, 5, -2. That's my minimum. Next interval, which is 0, we're going to follow the pattern. So we're down in the minimum, now we go back up to the midline. And then we go up to the maximum, we keep going up. So our maximum we already know is 8. Then we go back down to the midline, and we go back down to our minimum, which again is 5 down, -2. And then we go back up to our midline. You know that you have enough points when you have 9 points total. So it never hurts to take a moment to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. If you don't have 9, then you need to keep going. Or maybe you skipped one by chance. After that, just sketch in the curve. And if this were to keep going, we had minimum, midline, it would go up again to the maximum. So I'll draw an up arrow there. And there we have our completed curve. Last but not least, the range. This is the minimum to the maximum. Also, it's the two numbers that it toggles between on the y-axis. That's from -2 up to 8. And there you have it. Number 2, y equals -2 cosine of 4x minus 2. Take notice that you have a reflection here. That's what that negative in front means. So I always put that next to my amplitude just as a reminder. This is not required to get full credit, but it's just a reminder again. So when I set up my general equation, I have y equals a cosine of bx plus c plus d. This time when I make my little drawing, I'm going to remember that I have a reflection, so that's actually going to change how I draw this. So for cosine, again, if we have our starting point at the origin, a normal cosine starts up at its maximum, but since we have a reflection here, I'm actually going to put the first point down at its minimum. It's going to do the exact opposite. Then we follow the pattern. Up to the midline, up to the maximum. Down to the midline, down to the minimum. And then when we connect it, it should look like this. Cosine has a U-curve. And when it's reflected, it just looks like an upside down U. Filling in the info, amplitude, again, absolute value of A. This is where absolute value is really important and reminds you that when you write this down, you're still going to write +2, not -2. Period, 2 pi over b. This time my b is not 1. I do have a number in front of the x, and it is 4. Reducing, pi over 2. Interval, period over 4. Period is pi over 2. Over 4. Now the quick trick here, when you have this set up, you have a fraction divided by a number. You just multiply, quote unquote, the two denominators, if you will. 2 times 4 is 8, so the new number is pi over 8. If that explanation doesn't work for you, I'm going to work out the full problem here just to show you that it does, in fact, give you pi over 8. I'm going to do that down here. Pi over 2 divided by 4. Let's just write this out for what it is. Pi over 2 divided by 4. Anytime you have division involving a fraction, the rule is keep, change, flip, or multiplying by the reciprocal. So we have pi over 2 times 1/4. And then when you multiply straight across, it's pi over 8, which is what I already had above. So you can do it that way if you'd like as well. Phase shift again. It's bx plus c equal to 0. Just set what's inside the parentheses equal to 0. That work is pretty short, so I'll do it right next to the blank here. So we have 4x equal to 0. And if I solve for x, divide by 4 on both sides, x is still 0. So you can either write x equals 0, or you can write none. Because if this is what you get, that means there is no shift left or right. It stays where it's at. Vertical shift at the end, our d value is -2. Domain, always the infinities. Range will be determined later. Let's graph this. Setting up our graph with the intervals, our intervals are pi over 8. Again, I'll do the unreduced fractions first. First interval here, 1 pi over 8. Second interval, 2 pi over 8. 3 pi over 8. 4 pi over 8. Reducing, where possible. We'll just say pi over 8 here. This reduces to pi over 4. 3 pi over 8 does not reduce. 4 pi over 8 is 1/2, so pi over 2. Negatives, repeat the numbers but put a negative on them. Negative pi over 8, negative pi over 4, negative 3 pi over 8, negative pi over 2. Now we need to figure out where we're starting. Again, make sure your period lines up with the last interval. Phase shift, we have none this time. We do have a vertical shift of -2. So we're going to go down to -2. And since this is my only shift, I can go ahead and place my circle here. Horizontal line through that for the vertical shift. Vertical shift of -2. And then we can start graphing. So cosine, again, since it's reflected, we'll start down at its minimum instead of up at its maximum like it's supposed to. And the minimum is based on the amplitude. So the amplitude is 2. So from my starting point, I'll go down 2. My minimum of this graph is -4. And then we're going to go over each of the intervals. This time I'm visually closer to the numbers, so tick marks aren't necessary, but again, if it helps, it helps. I'll fill them in real quick. This time we're going to be evenly split, 4 left and 4 right. So we're at the minimum. Next interval, we're on the midline. Next interval at the maximum, I need to go to my amplitude. It's 2. So we're going up 2 from the midline, putting us at 0, or on the x-axis, however you see that. Next, we have on the midline again, down to the midline, and then again back down to the minimum to create that upside down U-shaped curve. And if I were to keep going, I would be going back up. Here's half of my graph. Let's finish the other half. Cosine, thankfully, is a mirror, so I will repeat these exact points going to the left. First point to the left, we're up to the midline. Then we're up to the maximum. Back down to the midline. Back down to the minimum. Again, amplitude, we're going up 2 and down 2 the whole way. And there's our curve. Lastly, the range. This toggles between -4 and 0. There's our completed graph. Two cosine of 2x plus pi minus 1. Start with the general info. Y equals a cosine of bx plus c plus d. Mini curve. With our 4 intervals. Assuming we start on the origin. So we don't have a reflected cosine this time. The a is positive. So we're going to start like we're supposed to. Cosine starts up at its maximum. Then it goes to its midline. Then its minimum. Then back up to its midline, back up to its maximum. And this looks like the proper U curve that I like to use to describe this. Amplitude, absolute value of A. A here is already positive, it's 2. Period, 2 pi over B. 2 pi over B here is 2. Reducing this, we get pi. Interval is period over 4. So that's pi over 4. And that's all there is to do there. Can't reduce that, so it's just pi over 4. Phase shift again, we set the bx plus c, what's in parentheses, equal to 0 and solve. And as you can see, that's going to take a little bit of work, so I'm going to come down here for that part. Phase shift, inside of parentheses, we have 2x plus pi. equals 0, and we'll solve. Reminder, the goal here is to get x by itself. So if you ever get stuck on what you're doing, remember that goal. First thing we'll do is get rid of pi right here. Pi is our constant. It is a number just like any other. It just looks like a symbol. So we'll subtract pi over here. That leaves us with 2x. And then to get the x by itself, we'll divide off the 2 on both sides. X equals negative pi over 2. Just like that. Vertical shift at the end here, a negative 1. So our d value is a negative 1. Domain, always the infinities, per usual. Range will be determined at the end of the problem. Let's set up our graph. Again, I'll start out with the unreduced fractions and then go from there. First interval is pi over 4. And this is 1 pi over 4. And going up, we have 2 pi over 4, 3 pi over 4, 4 pi over 4.
The time is now 3:06. Please release.
From here, I'm going to reduce my fractions where I can. So this I'll just write as pi over 4. 2 pi over 4, that's a half. Pi over 2. 3 pi over 4 is the same. 4 pi over 4, that's just 1 pi or pi. And the negatives. Negative pi over 4, negative pi over 2. Negative 3 pi over 4. Negative pi. Next, we need to figure out where exactly we're going to start. Phase shift is negative pi over 2. So that's here. I'm going to draw my vertical line through that. And I'll label it. Phase shift, x equals negative pi over 2. And again, I do this as a way just to double check, make sure I put it in the right place. Again, it happens sometimes where you put it in the wrong spot. And then vertical shift is negative 1, down 1. Horizontal line for that one, through negative 1. Vertical shift, negative 1. Where they cross is where I start, or at least place my new origin. All right. And again, this is where it may be helpful to put in some notches, since this is our new midline, especially on 0. A lot of students like to skip 0 when we're not on the y-axis to start. There you go. Got my H total notches. 9 total, if you include the starting point. All right, let's start graphing. So we start here, and per my little drawing, we start at the maximum. So we're going to go up 2. That's what the amplitude tells me. 1, 2. We're going to start at 1. And then I'll go to the right to start. To the right, we're down at the midline. Next notch, which is at 0 on the x-axis, sitting directly on the y-axis, we're going to go down to the minimum. We went up 2. We're going to go down 2. Negative 3. And then we're going to work back up. Next interval, we're up at the midline. Next interval, we're back up at the maximum. And we're going to keep going. Next interval, we're back down at the midline. Next interval, we're back down at the minimum. Almost went too far. Down 2. And that was my last notch, so I'm going to stop there. I'll draw the curve I have so far. And if this were to continue, it would go back up. We're almost done with this graph. We just got to go 2 more to the left to complete it. We're at the maximum, so the only choice we have is to go down. We'll go down, make a pit stop at the midline first, and then down again to the minimum. And finish the curve. And then it would go back up from there. Once again, make sure you have 9 points on your graph before you move on. 1, 2, 3, 4, 5, 6, 7, 8, 9. Range, this toggles between negative 3 and positive 1 on the y-axis. And there you have it. One more graph. Y equals negative, notice it, we have a reflection here. Right off the bat, that should draw your attention. Negative 3 sine of x plus pi over 2. I'll start with the general stuff. Y equals a sine of bx plus c in parentheses plus d at the end. And then my mini graph. For this, it's really important that I went ahead and noticed the reflection because it's going to change my mini graph here. All right. Starting point on the origin. This is a sine graph. Sine is the S shape and it starts inside the circle. Regardless if I have a reflection, this isn't going to change. What will change? Sine from the first point usually goes up after that. Since it's a reflection, I'm going to go down. That's what's going to change. So we're going to go down to the minimum. Then we go follow the pattern. Up to the midline, up to the maximum. Then back down to the midline. That's 4 intervals there. And it still has a nice S shape if it's reflected. Amplitude, remember absolute value of A, it has to be positive. So we'll still write positive 3. Period, 2 pi over B. 2 pi over my B, this time again is a 1, so it's just a nice 2 pi. Interval, period over 4. Period is 2 pi, so 2 pi over 4. Reduce, 1/2, which is just pi over 2. Phase shift, put the bx plus c equal to 0. And this really doesn't require much work, but I'll come down here to do it. In the parentheses, I have x plus pi over 2. Set it equal to 0. Because of the fraction, some students like to get fancy with this. Don't overthink it. Get the x by itself. I need to move pi over 2 over here. So I'm going to subtract it. This will become negative pi over 2 on the right side. And we just have that. X equals negative pi over 2. That's our phase shift. Vertical shift, the d value at the end. And in this case, there is nothing there. It is blank. So it's 0. You can write d equals 0, or you can write none. Both answers are correct. That just means we don't have a vertical shift. Domain, the infinities, negative to positive. Put them in the right order, please. Range we'll get to later. Let's set up the graph. Intervals first. Pi over 2. And we did this on an earlier problem, I believe, so these numbers should definitely ring a bell. Pi over 2 is my first one. 1 pi over 2. 2 pi over 2. 3 pi over 2. And 4 pi over 2. I will reduce where I can. I'll drop the 1 and just write pi over 2. 2 pi over 2, that reduces to just pi. 3 pi over 2. 4 pi over 2 reduces to 2 pi. And the negatives, negative pi over 2. Negative pi. Negative 3 pi over 2. Negative 2 pi. Let's figure out where we're starting. We have a phase shift of negative pi over 2. Just through this here, so we're left pi over 2. Phase shift, x equals negative pi over 2. Once again, this is just a very convenient way to check and make sure I put it in the right spot. And there's no vertical shift. So our midline is still where it was to begin with on the x-axis. So you can draw it over it if you'd like, or just at least highlight the ends just for emphasis. We're still starting here. So we're starting here to be exact. So we just moved over 1. That's it. Didn't move up or down. From here, we'll graph our points. We're going to follow the mini graph I drew above. And the intervals are exactly where they're supposed to be already, so I don't have to worry about missing anything, although I will highlight the 0 just to make sure I don't miss it. So we're starting in the circle according to my image up there. Next interval, which is 0, we go down to the minimum, and according to my amplitude I'm going to go down 3, so that's going to put me right at -3. Next interval, we go back up to the midline. Next interval, we go up to the maximum. Amplitude is 3, so we go up 3, up to +3. 1, 2, 3. And then next interval, we're back down to the midline. And then next interval, we're back down to the minimum. And I'm going to stop there because that is my last interval that I labeled. Go ahead and draw my curve. And then if this were to keep going, it would go up. Now let's go to the left, and we need to go 1, 2, 3 more to the left specifically. Remember, sine is not a mirror, so it's not going to go down again. And think about it, if I went down, that would completely disrupt the pattern I've started over here. That wouldn't make sense. It's down to the right, so we're going to go up to our maximum to the left. Just think about it. Next, midline. So maximum, midline, back down to the minimum. That was my last interval that I labeled, so I can stop there. And then if this were to keep going, it would go back up. Once again, make sure you have 9 points. 1, 2, 3, 4, 5, 6, 7, 8, 9. And lastly, range. Again, it toggles between -3 and +3 this time. There's our range. We're done with graphing specifically from start to finish. Next, we have graphs to equations. So picking apart a graph, if you will. I'm going to warn you, these are a bit tougher than the ones we did in class, so you're really going to want to mark these up, break them down, do what you need to do to make the graph make sense. So first off, I'm going to write the basic general equation at the top that we're going to use to make our sine and cosine equations. These are slightly different from the equations I just used in the past 4 problems. So I'm going to write them out. So for sine, we have y equals plus or minus a sine of b is on the outside of the parentheses. In parentheses, we have x minus the phase shift plus the vertical shift at the end. Cosine, of course, is going to be exactly the same, but with cosine, so I'm going to write it again. Y equals plus or minus a cosine of b, x minus phase shift, plus the vertical shift. Okay. So write a sine and a cosine equation for each graph below. Something that's really helpful to know is from each equation to the next, the things that stay the same. The value of a, now plus or minus can change, so it's not always going to be the same sign, but a will be exactly the same, b will be the same, and the vertical shift will be the same. Phase shift will change from one equation to the next. It must change. These cannot have the same phase shift. So it helps when you're going through this to first identify a, b, and vertical shift, and then from there we'll build the equations uniquely. So for this graph, you want to kind of have some markings similar to what we would have when we make our own graph. So one of the first things I like to find is the midline, and that's really easy. You can kind of eyeball it if it helps, but if you can't eyeball it, find your maximum. Our maximum here is 1, and your minimum is -5. So it's the number halfway between 1 and -5, and this graph kind of gives it away. It's -2. But if you're not sure, find what you think the number is, and then count up and down and make sure it's the same distance away from both numbers. So we have 1, 2, 3, 1, 2, 3. Yes. This is our midline. So find the midline. That really helps you visualize what's going on here. This is also your vertical shift if you have one. Since it's at -2, we do have a vertical shift of -2. So like I said, the information you want to find first is A, B, and the vertical shift, because those don't change from equation to equation. We've already found the vertical shift. It's -2. Once you find that, finding A is really easy. I actually have already found it technically. Remember, A tells you how far up and down you go from the midline. So if I count up, it's 1, 2, 3. Be careful, the notches are kind of weird here. It's 3 up, or you can go down. 1, 2, 3. It's 3 either way. A is 3. And then B. A lot of students try to find B every single time they make a new equation. You can do that, but B is not going to change. So once you find B, you're good. You have what B is. Now, the easiest way to find B is to first identify a full curve in your problem. Because, reminder, to find B, you use the formula. I'll write it in black. Period equals 2 pi over B. So we need to find B, and in order to do that, we must first find the period. And this is done by looking at the graph. A period, remember, is a one curve. Now this curve can be sine or cosine, it doesn't matter. They both have the same length when they're on the same graph. You just have to identify one. When we are this zoomed in on the graph, we don't have many choices for our curve. So there is one curve, and I hope you see it. It's a sine curve from start to finish. If I start here at -2 pi and follow it through, I make one complete S. So this is the curve I'm going to be using here. So again, if we start here and we highlight, that's my sine curve. And I drew my starting point here. Notice I'm not on the origin, I'm shifted left, so I will draw in that phase shift line since I have a phase shift here. -2 pi. I could go ahead and set up and fill that in the equation right now, but I'll come back and do that later. I just conveniently chose sine because it was the one full curve I could see. So one curve for the period. So first off, let's find the period. Our period goes from -2 pi to +2 pi. That's where it ends. And if you remember the calculation I showed you in class, because some of you can like kind of mentally see what's going on here, so you can mentally calculate that distance. But if you're a bit struggling with that, that's fine. Also, it's nice to have a calculation that works every time. So the calculation is right minus left. This will help take care of any negatives when those come up like we have right now. Our right number is 2 pi. It's +2 pi. Minus our left number is -2 pi. So, as you know, two negatives make a positive. This is 2 pi plus 2 pi, which gives us 4 pi. So our period is 4 pi. So now I can finally solve for B. So period is 4 pi equals 2 pi over B. There are a couple ways to solve this. I like cross multiplying personally. We'll drop a 1 under the 4 pi so we can cross. Crossing, we have 4 pi times B equals 2 pi times 1, that's just 2 pi. And then divide off 4 pi on both sides to solve for B. 4 pi's cancel completely on the left. On the right, just the pi's cancel. b equals 2/4, which is 1/2. All right, I have found the starter information. Now I'm going to work on setting up my equations. And I'm going to follow along this green equation at the top for the sine function, and every time I hit a letter, I'm going to leave a space, although I have found pretty much all of this information at this point in time. Y equals, and you can draw a blank or just leave physical space, it doesn't matter. Sine x minus the phase shift plus the vertical shift. And thankfully, I've already done all this work, so I can just fill these things in. A is 3, and now be careful here with that plus or minus. You have to ask yourself, is this sine curve reflected or not? So I already labeled my starting point for this sine curve. It's here, and it goes down from there. If it goes down after you start, it's a negative. So this is a reflected sine curve. From here, our b value we found is 1/2. X minus our phase shift, this is unique to this curve. Our phase shift is at -2 pi, so I'm going to fill in exactly that, negative and all. Plus the vertical shift is -2. That does not change from one equation to the other. So this equation's pretty good. The one thing I'm going to fix here, when you have minus negative in your equation, fix that, turn it into a positive. So it's x plus 2 pi. It's the proper way to write that. This is my sine equation. Cosine equation, I'm going to set it up. Y equals, we have the a value, cosine of the b value, x minus the phase shift, plus the vertical shift. As I stated before, when we go from one equation to the next, the a is the same. Now the sign in front of it may or may not change. So I'm going to put a little circle there. So when I figure out where my cosine curve is, I can figure out if this is a positive or a negative in here. Cosine of b does not change. It's still 1/2. Phase shift will absolutely change. I'm going to come to that later. Vertical shift does not change. Now I need to find a cosine curve. So remember, a sine curve looks like an S. And that's one direction, and then the other is like that. That's reflected. Cosine, if it's not reflected, just looks like a U. And then if it is reflected, it's upside down from that. So we're looking for either of these in our graph. One easy way to do that is to either find maxes or mins. Either one will help us identify that. So hopefully you can find that U shape. We can't start it here because this is the midline where this point is starting at. Cosine either starts high or low, but it never starts in the middle. So we have two cosine starting point options here. We can either start low at the minimum or high at this maximum. Both of these are good starting places. And I feel like a lot of you would tend towards starting at a maximum because that's the normal cosine curve, the unreflected. So I'm going to choose this pi over here, but you could also choose the -pi. So this is going to be my phase shift. And remember, you always put the starting circle on the midline itself. So this is my phase shift, and it is positive pi. And if I start here, I would start, this is a maximum, this is where the point actually starts on the graph, and then it would go down, and it would go down, and it would eventually make a U shape. Unfortunately, you can't see much of the graph, so that doesn't help. But this is the start of a cosine curve. So let's discuss a couple things. First, is it a reflection? This is starting at the maximum like it's supposed to on a cosine curve, so this is a positive 3, not reflected. If you chose to start at -pi instead, because you can clearly see the U shape here, it's upside down, this is reflected. So this would be negative if you chose this to start instead. And then from here, this is a phase shift at positive pi. So I'm just going to fill that in like so. So I'm just going to write pi. And there's really nothing to fix here. This equation is awesome. It looks really good, so I'm going to leave it. This is my equation. Again, your other option would have been to start at negative pi. That would have changed this to a plus here. And then you would have been starting at a minimum, making this a reflected 3 instead, a negative 3. Otherwise, that's how you do these problems. Let's do another one, B. This is more like what you saw in class, where you have a lot of curves to choose from. So there's a lot of options for equations. Again, let's kind of just pick this graph apart a bit. Very first thing you want to find is the midline. So find the max and min. We go from -2 all the way up to 6. Quick math there, that is a distance of 8. So the middle is going to be 4 away. Also, the graph gives it away where it crosses the y-axis. 2 is more than likely going to be your midline. Count, just to be sure. 1, 2, 3, 4. 1, 2, 3, 4. Yes. So this is the middle of the graph, the midline. So midline, this is also our vertical shift through 2. So it goes up 2. Finding the essential starter information, A, B, and vertical shift. The stuff that doesn't change. Vertical shift I have found is +2. A, I've already mentioned, the distance from the midline to the max and the min, it's 4, no matter which way you count. So A is 4. B is what takes the longest to find. So for B, you want to find a nice curve to identify the period, because again, to find B, you have to have the period first. This time, we have the convenience of being able to start on the 0 and follow that curve, whatever it makes. Since 0 starts on, or since our point here starts on the circle, that means this is a sine curve. When I follow it, it's going to create that S. So follow it through till you create a full S curve from start to finish. We're starting on the midline, max, min, ending on the midline. This is 1S. This is sine. And since we're starting at 0 on the x-axis, there is no phase shift. And I can even kind of make a note about that. Phase shift, we're at 0 on the x-axis. So, no phase shift. All right, let's find B. Again, the formula is period equals 2 pi over B. Now, when possible, a lot of students like to go the route I just did, because finding the period is really easy when you start at 0, because you go out a full curve and the number you stop at is the period. So, and since I have room, I'll go ahead and write it out. So our period goes from, our curve, period, goes from 0 to pi. So from 0 to pi, that's a distance of pi. Period is pi. So we can jump right into solving here. Period is pi. We have pi equals 2 pi over b. To solve, I'm going to drop a 1 under the pi and cross multiply. We have pi times b equals 2 pi. If at this point you can clearly see what b is, you can jump ahead and just write what b is. But if you can't see it, we'll continue. Get b by itself, we'll divide by pi on both sides. Pi's cancel on the left and the right. B is 2. Now I have found my essential information to build my equations, and I've gone ahead and identified a sine curve to start with. So I'm going to set up my equation, y equals, leaving spaces. This time I'll just leave spaces and not write blanks. So you have the general equation above. Remember, first we have the a value in front. We know that a is 4. And we have to ask ourselves, is this a positive or negative 4? Let's look at our sine curve. Sine, after the starting point goes up like it's supposed to, this is positive. You can also just remember that up is positive if it helps. Sine B is 2. X minus my phase shift, I've already labeled it earlier. I started at the origin, it's just shifted up 1, so it's at 0. We did not shift left or right here. So this is unique to this equation, 0, plus my vertical shift, which is just a +2. So I'm going to put a 2 in there. There's my sine equation. The only thing I would change would be getting rid of the -0 here, but this is perfectly fine. Cosine equation, y equals, leaving space for the a, cosine, space for the b, x minus whatever the phase shift is, plus the vertical shift. Filling in. And before I do that, let's find a cosine curve to work with. Now, be careful what you choose here. There's something about this graph that makes it not so nice, but you have options. So let me go ahead and cut to the chase. Cosine, again, you're looking for a U shape, and it can be U up or U down, up to you. But you want to find where it starts. It's either going to start at a maximum or start at a minimum. So we have a U here, 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 and here. Those are all non-reflected U's because they're all upward. Or you can look at the reverse, the downward U's. So each time I start and stop, that's a full cosine curve. You have a lot of options here, but hopefully you notice. So like all the maxes, got 4 of them here, and all the mins, they're at these intervals in between them labeled, -2 pi, negative pi, 0. They're not on labeled intervals. So we have to stop real quick and figure out what these intervals are. So this is where it's helpful to identify the individual points on the graph like we normally would graph. Normally we don't have to go in depth on these problems, but because we're missing labels on our graph, we don't really have a choice. So I'm going to label these real quick. We've got starting point, max, midline, min, midline, max, midline, min, midline, and that's all I can see. Now, I could label the whole graph, but I'll go ahead and tell you. I'm going to intentionally work on the right side. That's one of the most convenient ways to go about this problem. So I'm going to start here. So here's kind of like the key advice. Once you find your curve, and a lot of us start with sine curves, that's just how it works. Whatever your sine starting point is, shift 1 point left or right, you're going to be at a cosine curve. So if I shift to the right, that next point is at a maximum. This is the start of a cosine curve. So this is where I'm going to begin my curve for cosine. So yes, the coloring is going to overlap, but that's okay. Just make a full U. So I'm going to go a little further than the sine curve started or ended. So the green is my sine, and then the orange is my cosine. So I started here, and we have to figure out where here is because there's no number there. All right, so we know this is 0, and we know that this is pi. And let's label our intervals in between just to really make apparent what's going on here. So we got a point here, so this is an interval. This is an interval, this is an interval. We have 4 intervals in between here. So 0 to pi, and these are each one of 4 intervals. So essentially, if this is a full period, pi over 4, then back what we're used to, our interval is period over 4. And again, we found our period earlier. It's pi over 4. Pi, sorry. So pi over 4 is each interval. So that's what each of these lines are here. These are each a pi over 4. So I can label all of them, or I could just label the one I need. Choice is yours. But we now know that this next interval over is pi over 4. If I kept going, we've got pi over 2, 3 pi over 4, and then just pi. Those numbers should definitely ring a bell. We've worked with them quite a bit already. So my phase shift is at pi over 4. And now we know cosine, its phase shift is pi over 4 here. All right, let's go back and fill everything else in order. Once we identify the phase shift, everything else falls into place. Our A value, again, the number doesn't change, but the sign might. Let's take a look. We start up at the maximum. That's on a positive note, so it is positive. And it's an upward U. I intentionally went for that. After cosine, we write the B value. Again, B does not change. It affects the whole graph. And then vertical shift does not change either, so it's going to be the same. So on those problems, these graphs where not every interval is labeled, that's going to create a little more work for yourself. Remember, you know how to find the interval. It's just the period over 4. You just have to remember that. We do that all the time when we graph. All right, we saved the best for last, and I'm not being sarcastic. Words to equations are a very nice, just kind of softball problem, just to finish it off. So we're going to write equations, but this time they have to tell us directly the information that we need. Write the sine function with the given information. Amplitude is 5, period is 6 pi, vertical shift is 6, phase shift is negative pi over 3, and it's a reflection across the x-axis. I'm going to set up my equation. Y equals, leave some space for the A, sine, leave space for the B, x minus, leave space for the phase shift, plus vertical shift. Filling in from the directions, amplitude is 5, and I'm going to jump ahead here. There's a reflection across the x-axis mentioned at the end, so this is a negative 5. So I've taken care of amplitude and the reflection. Period is 6 pi. That information is given so that we can find B. So let's do that. B is equal, to find B, we use period equals 2 pi over B. Period, we are told directly, is 6 pi. Equals 2 pi over B. Solve, we're going to drop a 1 under 6 pi and cross multiply. We have 6 pi times B equals, this is just 2 pi. Divide off 6 pi on both sides. 6 pi cancels on the left completely. Right side, just the pi's cancel. B equals 2 over 6 reduces to 1/3. So we have a 1/3 in for our B value. We're done with the period info. Vertical shift is a positive 6, so I'll just fill that in at the end. Phase shift is negative pi over 3. Done with that. One last thing, reminder, if you end up with a minus negative inside of here, I do need you to change that to a plus. However that looks, if you're writing in pencil, just erase and change it to a positive. But I'm in marker, so I'm going to just make that a nice big plus sign. And there's our equation. One more. Number 7, same thing, but it's cosine. I'm going to set it up real quick. Y equals A cosine B, x minus phase shift plus vertical shift. Amplitude is 3. No mention of a reflection here, so I know it's positive. Period is 2 pi. Again, we're told that so we can find B. Period equals 2 pi over B. We know that the period is 2 pi. So 2 pi equals 2 pi over B. Again, just by looking at it, I'm sure several of you know what it already is, but if not, We're going to keep solving. Drop a 1 under there and cross multiply. This is 2 pi times b equals just 2 pi. Divide off the 2 pi on both sides. This cancels completely on the left. B equals, dividing a number by itself gives 1. So B is 1. Done with period. Vertical shift, -3 at the end. Phase shift is just pi. So I'll fill that in. Now it looks like a negative pi, but we understand that it still means it's a positive movement when we take it out of the equation. And there you have it. That is the last problem. That's the end of the study guide. I hope that this video helped. If you have any questions, please come talk to me either in person when you see me or via email. I'll be happy to take your questions still. Otherwise, I hope you all have an awesome day. Bye!